Right. Hello, everyone, and thanks for coming. This is Training Chatbots and Conversational Intelligence Agents with Amazon Mechanical Turk and Facebook's Parlay. And I'm Jack Urbanak. So a quick overview of what we're going to be talking about. First off, I'm going to be describing what Parlay is and what issues we're trying to solve. I'm going to give a brief intro of Mechanical Turk for anyone who who hasn't used it in the past. I'm going to talk about how we collect conversational data with Mechanical Turk and also how we evaluate our conversational agents with Mechanical Turk. I'm going to talk about optimizing for the human element, the lessons that I've learned along the way of working with Mechanical Turk on our platform. And then I'm going to talk about how to leverage Parlay for your specific problems, your conversational agents, and whatever you might want. So a little background of me. I'm a research engineer on Facebook's AI research team. I'm an engineer on the Parlay team. I'm the primary contributor to Parlay's Mechanical Turk implementation, and I've also used it for data collection for a few projects now. So let's start off with why Parlay. Why does this thing exist, and why am I here talking to you about it? So first off, a little bit on the side of natural language processing to get us all on the same page. NLP is difficult because language is imprecise. There are often hundreds of ways that you can say the same thing and hundreds of interpretations for one thing depending on the context. Despite that, there's generally one fundamental goal, and that's enabling some clear dialogue between humans and computers. One way that you can break up the idea of these dialogues is that they're actually individual tasks, thousands of them, but they each have different skills required for them. So that might be something from having a chit-chat-based conversation to answering questions to booking a restaurant. These are all using the same format of language, but they're individual tasks. Now, one thing that happens because of that is that most NLP research attempts are siloed. They go into one or two or a very small subset of these tasks and try to really optimize for whatever the task they're trying to solve is. But that leads us to a specific problem, and that, take two dialogue tasks. One of them question answering and the other one chit chat. One very popular question answering data set right now is Stanford's SQUAD data set, which takes a Wikipedia paragraph and a question as a pair, and then it responds with the indices of the answer to that question in the paragraph. Now, people really try hard to make models for this and to make it work. But one problem is that if you do make a model for this work very well, it's not going to generalize to the chit-chat task. If you try to talk to it, it's going to just answer with indices, and that's not really what we're looking for, even though they share the same core of contextual language understanding. And this is something that pops up with more than just this construed example that you really can't always get these tasks to overlap based on the input and output formats that people have set up. And we feel that that's kind of a problem because you're not really working together towards the overall problem of NLP. You're working on these really small subsets. So that's kind of our thought. Why would we have a dialogue research platform? Well, if we bring all these tasks into one place and make it so that you have one agent and can expose it to any of these tasks, both for learning and for then testing, it might be able to gain a higher level of natural language processing understanding. And so we thought that having this standardized method for training and data collection would have more people come together and work on more than just the task that they were initially thinking about. And this could be helpful in the case of if you were trying to have a customer service bot, but you were just working off of customer service data. If a user then tried to have a conversation with it, it would break down and not really know what to do. While if you had the ability to also train it on some chit-chat, it might be able to at least field that in a way that wasn't a broken experience. And so we feel that there's definitely a use for this kind of platform. As far as where we are with it right now, we have a unified framework for actually testing and training these models. We have a bunch of tasks like chit-chat and question answering and many others that you can train and evaluate using. You're able to train your agent on multiple tasks at the same time without needing to do anything separate. You just queue up which tasks you want it to learn from, and then it can learn. We support both supervised and interactive tasks, meaning you can do your labeled things, but you can also work on reinforcement learning. We support images. We have a bunch of existing models that you can use to start from and to move forward with. And we do data collection and model evaluation using Mechanical Turk, which is where I'm going to be getting into later. Another little tidbit is that we're open source and free to use, so we're definitely happy to take contributions and anything else. So on the task side of what we're able to do right now, we support question answering with or without visual grounding. We have sentence completion. We have full dialogues for chit-chat or completing goals. And we have additional tasks as well, such as negotiation and translation. This is a non-exhaustive list. We're currently at, I believe, 39 tasks and still growing day to day. So the basic idea of what we needed is we needed a framework for this kind of environment, something that could be generalized to any dialogue task that you might want, but isn't restricted in a way that would misconstrue these conversations. So we've done that by having these kinds of worlds which define your environment for interaction. We have agents, which are communicators in those worlds. We have teachers, which are a specific kind of agent that gives either labels, questions and label pairs, or it gives like an instance, expects a response, and then gives a reward. These are things that you can tune your model to kind of understand. And we also have actions, which are the dictionary and a kind of unit of communication for anything that happens within Parlay. So they pass text, labels, rewards, and then also additional grounding information if your tasks need them. As far as the actual implementations that we use, we can have a simple code that's on the left-hand side, which is just training a model. You instantiate your teacher and the agent that you have worked on, and then you put them in a world and you have the world parlay. And every single time the world parlays, it takes an example, it tries to teach it to the agent, and then it tells you how it does. We also have some code for the most simple kind of parlay which you could want, which is each of the agents acts and listens to everyone else's action. And that's just kind of like a round-robin conversation between your dialogue agents. So on the side of the agents that we already support, we have an LSTM model, we have a memory network, and we have a seek-to-seek model. All of these are things that have a baseline that you can work and build from. Depending on what your application is, you might want to test starting from these to see which one is giving you the best results and then move forward. We also have a few other agents that show that we can do different things within the Parlay worlds, which are like we have remote agents, which you can just connect to over 0MQL. We have local human, which actually lets you directly type in conversations with agents. And we also have the Mechanical Turk agent, which is where we're going to be getting into later. And that's the idea that you can get a Mechanical Turk worker to be in your Parlay world. We have more details and use instructions for these agents at our website. So towards where we're really heading, and that's the use of Mechanical Turk, I'm going to discuss a little bit about it, just in case you don't have prior knowledge, and then do a quick summary of what we're using Mechanical Turk for. So for the simple intro, Mechanical Turk is this crowdsourcing internet marketplace for any task that a computer can't currently do. So you as a requester, you will pay people to do bulk work that you wouldn't be able to do because you're working on other things. And then workers complete this work in the form of human intelligence tasks, which are hits, and then you get the results. Going a little bit more in depth, if you're using kind of vanilla Mechanical Turk, you have a templated workflow where you can select one of many standard tasks of like data collection, labeling, or surveys, or any number of things. And then you spin up a bunch of hits from that template. Workers work and complete the hit, and then you review that work and either accept or reject it. One thing to keep in mind, though, if you're rejecting the work, you're refusing to pay for it. So these are people, the workers on the other side, and this is their work. And if you continuously reject work for no real good reason, your reputation as a requester is going to suffer from that, and it's generally not a good thing to do. But more towards how we're using Mechanical Turk, we try to connect these workers together within a Parlay world. This way, as they act towards one another, we can record the conversations as data that we can then use to train our agents to do tasks that they couldn't do before. We're also able to have workers interact with a model directly and then have them rate their interaction. So that's what lets us do model evaluation. And then we also support automated review of this work where it makes sense to. This way, there's a way to either accept or reject directly in the workflow that you've set up. You don't need to manually go through all of them. And we did our best to make sure that our interactions with MTurk are almost entirely programmatic. So you don't actually have to go to the website to set up your hits or do anything like that. The moment that you've created your world, the Parlay platform will handle the rest and launch the hits and then keep track of them and everything else. So here's a quick little mock. Well, it's not a mock. It's actually what the MTurk functionality looks like, though I was all three parts in this case. So when you're first starting a hit, you kind of get this window where you have some details about the hit, and you can choose to accept the hit or move on. So they'll see a window like this when they're accepting. And then once they're accepted, they're thrown into kind of a waiting pool until someone else also joins, or however many people you would want in your conversation are there. And then they actually can start up. So I started as a local agent, and I typed a message that they saw, which was, is anyone else here hungry? I don't know, in case you wanted to have a conversation about people's food trends or something. And then the agent has the ability to interact with this as any regular chat window, saying, I definitely am. And then another one, oh, I just ate. And then I end the chat by saying, all right, that's all I wanted to know. And after both agents send a response, the hit is complete. And then we can collect this conversation data and put it in for one of our tasks. Of course, this isn't for a real task, but it does show the basic functionality. From this point, I want to talk about how we came to using Mechanical Turk for collecting conversational data and for evaluating models. Because both are very important parts to making sure that your conversational agents are up to par or of a high quality. So that's going to include talking about being able to support any tasks, talking about supporting multiple people at once, which isn't something that Mechanical Turk does natively, talking about actually preparing and getting these workers ready for these tasks, and finishing off with a little note on automated work approval. So the first element there is the idea that if you want to be able to have a conversational agent to do anything that you would be able to accomplish in conversation, you need to be able to have such an arbitrary conversation, meaning we as Parlay would need to be able to show these workers any number of things. So while a general conversation might be simple, might be just telling them to talk about a specific subject matter, it might be it might require a lot more than that if you want something that's more grounded. For example, if you're ordering movie tickets or you want agents to talk about a movie or, a video in real time. You would need to be able to render that video and have them talk about it and record the responses and everything like that. And it's just not something that can be done with a simple one input, one output situation. So we wanted kind of complete control. And we found our way to do that through Mechanical Turk's programmatic interface and support for external endpoints. So there's actually a way to point a Mechanical Turk hit towards any external information that you would want to. And so we were able to set up an external server, host the hit details and anything else we needed there externally, create this kind of external question hit that points to the server, and then collect the data from the server directly. So this way there wasn't really any restriction on what we'd be able to do. From that point, we also decided to make, or rather we strive to make it all programmatic. So there's no need to actually worry about setting up that server or creating the hit details or anything like that. Once you have your configuration set up, the rest happens just by running one of these collection tasks. So our implementation for doing that is, it starts off with having a set of hit details, which tells the workers what it is they're going to be doing and gives them context of the kind of data that you're collecting. On the front end, we have templated HTML and JavaScript, the goal being that for basic chats, we already support them out of the box, but if you want to be able to do something more complicated than that, you just need to override certain parts of the template. And the server itself is initialized on a per task basis. And the idea behind that is, since we're handling the setup and moving everything over, the users can set up these tasks without actually worrying about the external information or anything else. So in this case, creating complex tasks only requires the additional task-related code using the templates rather than having to do the whole thing from scratch again. The next problem is that the normal Mechanical Turk workflow doesn't natively line up with our use case. And that's generally because we want to have people talking to one another. And for the most part, Mechanical Turk is asynchronous, one worker, one task kind of situations. And initially, we thought this was a roadblock, but it turned out to not really be an issue because we had already set up one of these servers on our side. So all we needed to do was when workers accepted hits, we could just connect them and handle the content pass-through between the two. So we just link these hits together and have conversations on the server side. So in order to do that, we have the server act as a pass-through between the workers. And the workers' messages are handled as acts in Parlay, which are what I referred to before within a world. If an agent is required to act, it happens within the Parlay world, but the worker is able to actually lead that action. And then when the Parlay world tells a worker or an agent to observe, the Mechanical Turk agent receives that message. So one thing that's really useful about having this paradigm where it's still within the world is that it's very easy to swap out a Mechanical Turk agent for a pre-trained model, which means once you've set up your task for data collection initially, you can use the same task for testing your models and seeing people's responses, seeing how the workers feel they are doing, or any sort of model evaluation you might need. The next, and I feel this is actually one of the most important elements of this framework, is that it's not always clear to really anyone how to say that a worker is ready for a task. And the basic method for doing that right now is to have qualification tests, which are done externally to your task and are, for the most part, like a question-answer test. And that does cover a lot of cases, but we wanted people to be able to handle rather complex conversations that don't always make sense to have a test to do and might be very one-time specific. And we didn't feel like having workers complete or go out of their way to complete a test would really make sense towards getting them to work on our tasks. So we instead decided that it's better to onboard the workers within the task, and we provide some in-platform functionality for being able to do that. So our implementation is actually before the worker is added to a waiting pool, we can put them in an onboarding world. And these onboarding worlds generally follow one of two paradigms. Either it's just a set of turn-based steps where you're telling the worker what to expect and having them respond to advance the conversation, or you can have a mock of the real task with expected answers that you know are supposed to be correct. In either case, the upsides of having these onboarding worlds is that you're able to filter the workers from directly within the task. And the idea here is that instead of having a worker return multiple times and giving data that isn't necessarily up to what you need, you can have them filtered out after just the first task. The other thing that we're able to do is make sure that as workers return, they don't need to repeat the onboarding, which can feel to workers like it's a waste of time, especially if they already know what they're doing. So we can make it so that only the first time a worker tries out your task, they have to go through the steps of actually onboarding. And this is a little graphic of what the onboarding worlds do, where a worker tries to answer with something invalid, and then after answering with the correct answer, it says that it's putting them in the waiting pool. And then the last kind of major engineering thing that we worked on was automated approval of work. The main problem here is that models can require a lot of data to produce good results. And collecting that data, no matter how easy you make it to bring together, if that isn't up to what you need, if it isn't high quality data, you might find yourself going through every single example again, seeing if it's what you actually needed, and that can take even more time than it would to collect the data in the first place. So our solution was to kind of push for automated approval of work, and we did that with rule-based verification. That happens at the end of one of your data collection tasks. And the idea is, as you finish collecting data, if you have any sort of rule-based thing that you can establish, whether it's something really, really simple like you're trying to do a machine translation thing, and the responses aren't in the language that you expect them to be. That's something that you can easily rule out. Or a situation where you wanted your workers to talk about a specific animal, and that animal doesn't come up once in the conversation. Like, there are ways that you can, in certain cases, validate these just rule-based. But for more complicated examples, it becomes pretty difficult. So while we support this paradigm, we feel that it's generally less effective to be filtering through the work than it is to try and ensure receiving good work in the first place. And there's more on actually working towards having good tasks later in the slides. So the next part is I want to talk about the lessons that we learned trying to apply Mechanical Turk to our use case. And these are almost entirely based on what we found interacting with people and interacting with our workers. So for the most part, this is going to include understanding how worker interaction with tasks can affect your data or their experience. It's going to talk about disconnects and how those can really affect a worker's experience. And then I'm going to talk about both improving results by improving tasks and managing unintended task abuse. So the first part is that when we were just getting started, we didn't really understand the way that Mechanical Turk workers operated. And that kind of led to this disconnect where we had assumed that they'd be working in one way, but they just completely did something different. And in general, it makes sense for them because they're not on the side of requesting these tasks. They're finding a way to establish a work queue, working through it efficiently, and that disconnect kind of leads to unexpected behaviors. So in some of our initial tests, one of them was actually stalled completely because we had only launched 8 hits because we wanted to have 4 conversations, but one worker had queued up all 8 of those hits into their work queue, and no one else could take the work. So we were in this situation where we weren't going to pair a worker with themselves, but there was no one else to pair that worker with. And it required waiting 30 minutes for those tasks to expire before anything was actually able to be done. And that wasn't really a great experience for anyone who was trying to work out this task. And then after we kind of let the workers know that they weren't supposed to accept too many of these hits at the same time, we ran into another issue when a worker accepted one of these tasks but didn't work on it. And another worker, the other last worker in the pool, had accepted the task and worked through onboarding and finished the onboarding, but then there was no one on the other side and no other tasks to start. So they were waiting for 30 minutes for that task to be released so that they could have a partner. And also, this was a bad experience for everyone involved. And had we initially known how the workers would interact with our tasks, we might have done something differently. But we really solved this by just having a step of awareness later on that we would want to be clear with our intentions of how we expect the workers to work on our tasks, even if it's something that we thought was obvious from our perspective, because it's not always going to be the same idea. Another thing was that we started setting more reasonable task expiration times, because not all of our tasks required half an hour to complete. So it didn't make sense to have them expire after an entire half hour. That's just another little tidbit that made this work out. Now, one of the largest complaints that we had when we were just getting started was that suddenly a worker's work would disappear and they wouldn't be able to finish it. And they were saying that, I'm still here, I'm still trying to work on the hit, but nothing is happening. It just says waiting on the other person. And this kind of brings up the problem that workers, for any number of reasons, may disconnect and leave the other person or group of people in the conversation totally hanging. Now, regardless of the reason that this happens, be it that they need to step away to do something different for a while, or their internet drops out for some reason, or that they accidentally close their browser window, it's still not a good experience for the person on the other end, especially because, again, these are people and this is their work. And if they're in the middle of doing something and it just stops and they were halfway done and they were close to receiving their payment, it's essentially you're ripping away their work from them. And we kind of wanted to not have that be the case. And so we really tried our best to improve these situations. And the first one was we left the option to pay out to abandoned workers. And we think that this is actually a really important way to keep workers' trust in you as a requester. The idea here is that if they're in the middle of a task and someone leaves, they're still going to get paid for it because they were trying to do the work. And even though the work didn't get completed, they completed their side of the task. They were there and they were ready to have the conversation. So we don't pay out to the worker who disconnected. We instead, if they return to the page, we tell them that they had disconnected, and this means that they had not followed what we had expected for the work. But for the workers who were there, we do tell them that they can complete the hit. We also decided to allow these tasks to set a maximum act time before a worker is disconnected from inactivity. This means that there was no longer this situation where a worker left the browser window open but wasn't completing the conversation. After a certain amount of time, it would disconnect them, let them know that they were inactive for too long, and then pay out to the worker on the other side. In these cases, we would always let both parties know what had happened, and beforehand we would let workers know that if they were inactive for however long that period was, then they would be considered disconnected. We also made some changes to support reconnecting, so if you leave the page and come back, but you're still within that act time, you're still able to keep working. And we did our best to explain all other failure states to the user when and if they were to happen. And after we made these changes, we had found that the number of complaints that we were receiving per one of these that we launched fell down to maybe 1 or 2, when before they had been like 20 or 30 per like 100 or 200 hits that we had requested. And that was a huge drop. In fact, it was the largest one that we had while working through this. So now I feel like this is the most important element towards like making sure that you end up with whatever conversational agent that you want at the quality that you want it. And it's the idea that you can improve your results by improving the task itself. In general, this is a work situation, so the data that you're trying to collect for your agent is something that you're paying for. And as much as it's not fun to have a higher bill towards what you're trying to get, if you aren't paying out a reasonable rate for the tasks that you require for these conversations, we found that workers don't actually, like, they try to optimize their time for how much they're intending to make. And that means that they don't always spend as much time as you may expect or need them to, or put the kind of thought that you're initially thinking about, because you're not actually paying them for that time. You're paying them for like a smaller segment of it. So if the time spent isn't well compensated, you end up with a situation that the data you collect isn't always as useful as you want it to be. And that will lead to situations where down the road, if you're trying to train your models on these data sets that you've collected, they're not going to act as well as you want them to. So the first step is actually trying to work towards finding the right balance there, making sure that your tasks are properly compensated. And the next part is that when tasks are engaging, you end up with a lot more quality data coming out of it. And the rationale behind this is that workers aren't robots, they're people. If you make the tasks fun or rewarding, they enjoy the experience more and they put more of their thought and being into it. So if you improve their experience, it improves your data. And it also improves the general worker perception of you as a requester, meaning that more people are going to work on your tasks. They're going to go to their review boards and discuss and say, hey, this requester made some really interesting tasks and like you all should work on them. And the last side is that like workers aren't necessarily trying to be bad actors when you're trying to collect your data. The clarity that you put into your tasks is what leads to getting your quality data. If you make sure that there's no inconsistency or a misinterpretation of what it is that you're expecting they do, in general, they will do what you expect them to. All right, so while in general that is the case, there are still times where you find you've set up a task and you're trying to collect data, and the data that you're collecting is non-optimal in any number of ways. And in that case, it could be because a worker isn't prepared to work on your task or doesn't have a certain qualification. In those cases, that's something that we try to work out through the onboarding world, but it can still come up later on. And then in other cases, you'll find that workers will optimize an unclear or tedious problem in an unintended way. And that makes the data that they produce fairly invalid or otherwise unwanted. Now, to stop these, it's more of what I was mentioning before, that if you clarify the problem there and tell them that, like, hey, you're not supposed to solve these tasks in these ways, it means that you, first of all, will generally have workers that do the task correctly. And then second of all, it means that if you find workers that still aren't, there's a good reason for you to block them. And now, on the side of blocking, Parlay kind of supports two different ways to block a worker. The one that is generally supported by Mechanical Turk is a hard block, where you essentially block the worker from working on any of your tasks ever again. And it's somewhat discussed in the community of workers that these blocks can lead to accounts being suspended and any number of things. And in general, if you are blocking a lot of workers, it's going to reflect badly on you as a requester. So we also support something which is a softer case, a soft block, which lets you give a worker a qualification that's exclusive. So after they get that qualification, they're no longer able to work on your tasks, but they don't receive a hard block. And these are what you generally want to use unless you're positive that a worker is acting in an abusive way. All right, now to get towards more where you can be using Parlay for your goals. So for this, I'm going to talk about like how you would set up a world and the task that you need to collect the data that you might want for whatever your conversational agent is. I'm going to talk about how you actually create and run your set of hits. And then I'm going to briefly discuss extended use cases. So the mock example that I'm going to talk about is going to be this idea of collecting data for a customer service interaction. You can imagine this being something that you would want to have automated, where there's a customer who is trying to find out a problem with whatever their product is, and there's a service agent who is then trying to help them through it. And eventually you would want to be able to automate the service agent. So I'm going to do this situation in regards to fixing a router, but in order to kind of show off what Parlay can do on the grounding side, I'm going to give the customer actually the option to interact with their router, in this case through two very rudimentary buttons, but that's going to be what lets it be a real experience that they're trying to work through. So before we get there, we have to start up by setting up the hit details. And this is done by just creating one Python dictionary. And it has the hit title, which is the first thing that workers see. It'll have a hit description, which is a short form description for what it is that you're going to be expecting them to do. This is what happens when they click the title. They'll get like the extended description to see what it is they'd be working on. You put in some hit keywords, which are going to be things that they can search for. And then there's an extended task description, which, if you recall back to the initial page that they hit before they accept a task, that's where we give them the full task description. So this file is supposed to be able to catch a worker's attention and then give them an overview of what to expect. So for this mock hit, I have the hit title as simulating a customer service interaction. The description is play the role of either customer service or a customer with a problem and attempt to solve the problem through dialogue. I put a few keywords, which are chat, dialogue, and customer service, and then I have a longer form task description which describes how they're actually supposed to communicate and eventually work towards solving the problem. Actually setting up the Parlay world is going to be extending the existing Parlay world class. For the most part, much of the MTurk functionality can be customized by implementing a small number of functions, and most of the functionality can be altered just within our Parlay function, where a Parlay is kind of a unit of conversation. So there are stubs and examples of this available on our GitHub, but for this I kind of made a simple version where Parlay, if you hadn't initialized yet, it would send both the customer and the rep the same task. So they have the front end at least is able to get an idea of like what they're supposed to be rendering. And then from that point on, any other parlays that happen would let the customer act and process that customer act, and then let the representative act and process it. This can be done asynchronously. In this case, it's synchronous, so it's actually turn-based, but it's very possible to make actors be non-blocking. That can be done just by having a timeout on the act, and then it will let it continue for a regular chat window. But we've found that certain tasks that you were working on might not let you have that kind of setup. So we support both of them. Now, as far as actually processing those acts, there's this idea that we're not only sending messages between these users, we're able to send more than that. So in this case, the customer service agent is able to have an action rather than just a regular text message, and those can be things that like mark the task as resolved or do any number of things that you would expect from a customer service interaction, while the agent, or rather the customer, is able to have actions that that interact with the router that are trying to solve the problem. And these are then handled on the side of the world. The world is able to process them and figure out whether or not the task is actually completed. Now, once this world file is set up and you have a run surrounding it, you're able to just run the run.py file with a few flags, generally the number of conversations you want to have, how much you're going to pay for each of those conversations, whether or not you're going to be counting completed conversations, which are the situation that both agents have the conversation to completion and you've accepted it, or you're going to count attempted conversations if you don't give that flag. You can also run all of these hits on the sandbox server before you push them live, so you can see what they look like and how they feel. And then actually the most important one for this use case is probably unique. The idea is that a worker is only able to do your task, or this specific task, once. And you can imagine that if you're trying to collect data for a customer service interaction, you wouldn't want a worker to be both the customer service agent and then in the future the side of the customer, because then they already have knowledge of how they're supposed to fix the router. They already have seen the information that they're supposed to be giving themselves. And so they're able to kind of accelerate through the task in a way that they're not supposed to. And so it's useful to have these kinds of flags to be able to restrict that behavior and make sure that you're collecting good data. On the side of actually rendering this, we, as I had mentioned before, we have these templated HTML and JavaScript. So for grounded dialogue, you're often going to need more UI elements, and we provide the ability to use custom HTML in those templates. And you can also use additional JavaScript tied with those HTML elements to make sure that they are being processed by the world and being digested. So you're actually able to do things that are outside of just chatting. You can add additional elements and any number of data points that you might need. So since this information is sent from the Parlay world to be rendered on the front end, and then also sent in actions from the front end to the Parlay world, it's kind of still using the same language. So any number of agents that you set up or test or train using these should be able to still unpack that information because it's standard. So this is kind of the finished experience of what this specific mock looks like. So they get the information that is in the task description in the left-hand panel. And the right-hand panel is the general chat window, which you will always have when you set up one of these Parlay tasks. But the change here is that it also renders a grounding panel in the center. which is telling them that they are the customer, and it gives them two really simple options for things that they can do to try and fix their router. And the router itself is animated to, in this case, it blinks. So that's the indication that something is wrong. And they're supposed to talk with the service rep, who actually has the list of interactions that you're supposed to do to fix your router when it's broken. And so this kind of lets you collect the data of first trying to understand the problem, trying to build it down, and then once you figure out what's wrong, trying to explain how you would fix it. Both of these kind of views are using almost the same code, but are able to be split based on what the agent is supposed to be doing. And now I'm going to talk a little bit about extended use cases. I'm not going to go very in-depth to these because they're rather specific. So we can also do things like filter workers through requirements. Like as you're working on a task, you can decide that you want to have more strict requirements for future versions, and you already have a way to rate how workers are doing. You can set them up to give them a requirement straight off from within your world and then have them be able to access your harder hits in the future. You can do things like repeat role assignments, and this was actually something that's probably more useful than using the unique flag. This would mean that as you return to the world, you're always assigned the same role. So once a worker has been the customer, they will always be the customer, and once a worker has been the service rep, they might always be the service rep. This will make sure that you're not kind of polluting the information across that shouldn't be. You can do things like task experimentation. This is really useful on the data collection side, or model evaluation side, in that you can have multiple versions of the same model that you want people to evaluate, and you can submit them all in the same hit. And as they work through and kind of talk to your models, you receive data back in a form that you can actually see which one of your models is performing best. And then that works really well with this kind of idea that you can do hands-free iteration. You can create these models and have them run on Mechanical Turk, have people work through and test and see how good they are, and then respond back with that. That data comes back to you, and then you can pick the best one, make some slight changes to it via like some sort of parameter sweep, and then push it right back out and continue that in a kind of a circle until you have the model that you're looking for. So kind of the major takeaways that I would want to leave you all with is that when you're working with Mechanical Turk, there are kinds of things that you are capable of doing that you might not expect, but you have to be willing to experiment and kind of take things into your own hands like we did taking it onto our server. An important element is that workers are humans, and the better and clarified experiences are what are going to drive better data, and that better data is what's going to drive better models. On the side of actually collecting that data, Parlay MTurk is able to enable that data collection and model evaluation. And in the simple cases, it's done with almost no new code. You only need to set up that hit description. In more complicated grounded cases, you just need to have some JavaScript and HTML to support your world. And then the last bonus is that Parlay MTurk is still open source and growing, and so pull requests are always welcome, and ideas for features or other improvements may be addressed if they improve the way that Parlay supports this kind of research. Any questions? Mm-hmm. To do it, and you don't always have that many people who want your data. Right. So we didn't often run into a problem where we were waiting too long for workers. I think the longest time once we had this together was something like 1 minute to get something in. Though you're able to put things in onboarding worlds that, or rather in the waiting world, such that as the user is waiting for another person to join, they can work on something else that you might be wanting, and they can be awarded bonuses, which is something that we support as well. So then as they complete those mini tasks, you can give them bonuses along the way until you're actually giving them the full completion. Oh, yeah.
Can you talk about how this came about? Like, what was the use case that stimulated you to use or investigate mechanical turk?
Yeah, so on the Facebook AI research team, we have a team that's very focused on working on dialogue and different forms of dialogue and different kinds of agents, but we really didn't have a good way to collect data for when we wanted to do a new task, and no data set for it existed yet. And that's kind of a hard problem to solve, because if there's no data set for it, how are you going to get it? How are you going to train for that task? How are you going to make a model for it? And so in order to kind of make it so that any one of our members could do that, we worked towards this framework. I saw a question somewhere over near the back. Oh, yep.
So do you have any specific features in Parlay or in your framework to keep sensitive data kind of protected when you do hits? There's all kinds of personal data. You're asking people to upload all kinds of personal pictures and stuff. How do you make sure that that data is not exposed to hits?
Well, in general, Parlay isn't asking the workers for their personal data. We tried more to ask them to talk in general conversations or to simulate a conversation rather than do it themselves. Or not rather than do it themselves, but rather than do it from their own persona or personal experience. We feel that that generally leads to not having real personal data.
Now, if you want to actually train the model, you want to tag, for example, in ML, you want to tag something using hits, how would you go about doing that?
So if you're trying to, what do you mean by trying to train the model? First, you collect the data.
You want for supervised, you want to have tags
Yeah.
on your data.
Mm-hmm.
And you would possibly be using hits for tagging your data.
Oh, okay, I see what you're saying. So generally, the supervised versions that we have, the tags are something that are extractable from the responses themselves in an automated way. If you wanted to be able to have the data have different kinds of, because if you're having a dialogue agent, the expected tag would be more the response or the kind of response that you're going for. And if you already have collected a full conversation, you have the tag in what the next response is for each individual bit of data, though you can then later put those up to be tagged using Mechanical Turk's existing templates, if you would want. Yeah?
Some of us are trying to build, just for fun, a geography bebot. What states does the river Nile run through? So the question is, we've built a user interface kind of similar to this, but which is geared towards geography.
Mm-hmm.
Now, can we use that as an endpoint or with Parlay.ai, or we have to work within your environment?
So right now, we have it that you have to, it sets up our environment automatically, but that's not something that's too difficult to change and something that we'd be happy to support if we see that it's a use case that a lot of people are working towards. It's definitely not the first time that we've been asked to be able to support other servers or other endpoints, so it's potentially something we could be doing in the future.
Do you have, is there a service, a paid platform, or is it just an open source?
It's just open source.
Open source.
Mm-hmm. Oh, yeah.
Can you give examples of numbers of comments you've been able to get, or how big a data sets you've been able to build?
Off the top of my head, we had one that we needed to collect between 500 and 1,000 conversations, and we were able to get that within maybe 4 or 5 or 6 days, I think, was one of the kind of medium-sized ones we had to do. Though I'm not very knowledgeable on the actual specifics of maybe the largest thing that we've collected. I don't really see why there would be necessarily a limit, though, towards what we could collect, in that as long as workers are able to have a conversation more than once, which is going to be with a different worker, and in general, you're going to have conversations not with the same worker over and over, you're going to end up with a diverse set of data. Anyone else? All right. Thanks for coming.